Okay, we're going to go through topic 13a, geometric proofs involving congruent triangles. So first of all, a couple reminders. As you go through, when you're doing a proof, you always want to put the given stuff on your very first statement and your reason is given. And then as you go through, see what you have. When we talked the other day about checking for things like shared sides, vertical angles, parallel lines that might give you alternate interior angles, or possibly midpoints that might give you congruent segments. So you got to look for those even if it's not marked on the drawing. All right, so now we're given this. So that's our first statement. We have AB is congruent to FG. BC is congruent to GH. CA is congruent to HF. And our reason is given. Now, we want to mark this on our paper as well if it's not marked. So AB congruent to FG, that's BC congruent to GH, that is already marked. CA congruent to HF is not marked, so let's make sure we mark that one. Okay, so now we've gotten our information, and I'm trying to prove that this triangle is congruent to this triangle. Well, right now, we have 5 methods of proving triangles congruent. We know we can do it by side, side, side. We can do it by side, angle, side, angle, side, angle, angle, side, or hypotenuse, leg. So I want to look and see, do I have any of those things? And on this one, yeah, I have side. So these triangles are congruent because of side, side, side. So I can say triangle ABC is congruent to triangle FGH, and the reason is side, side, side. All right, let's try. I'm going to let you try number 2 on your own. So if you want to pause this right now and try number 2. All right, so hopefully you tried number 2 on your own. We're going to do the given part. BC is congruent to JK. DC is congruent to JI, and the measure of angle B is equal to the measure of angle K, which is 90 degrees, and the reason is given. So let's make sure we have everything marked. BC congruent to JK, that's been marked. DC congruent to JI has not been marked, so we're going to mark it. And angle B is congruent to angle K because they're 90 degrees, they're right angles, they're marked. All right. So on this one, I have a right triangle, I have hypotenuse and a leg. So I can prove these congruent by hypotenuse leg. Triangle DBC is congruent to triangle IKJ, and the reason is hypotenuse leg. All right, let's try number 3. Given BC is congruent to ZC. DC is congruent to CX, and the reason is given. Let's make sure those are marked. BC congruent to ZC, yes, that's marked. DC and CX, that is not marked, so let's make sure we mark that. Now, right now, I do not have enough, the way my drawing is, to mark these as congruent. But remember that we have to look for other things like shared sides, vertical angles, midpoints, parallel lines. And I can see right here I have a vertical angle. So I'm going to mark these vertical angles congruent. And now I have side, angle, side. But my first step here is to write why these are congruent, right? We can't say anything without a reason. So what I have is angle BCD is congruent to angle ZCX, and the reason is vertical angle theorem. And now I can say triangle BDC is congruent to triangle ZXC, and the reason is side, angle, side. All right, so try number 4 on your own. Pause the video, try to go through it. All right, so hopefully you've tried number 4. Here's our given. DCB is congruent to WCB, and angle W is congruent to angle D, and the reason is given. So let's make sure those are marked. DCB is congruent to WCB, those are marked. Angle W is congruent to angle D, that's not marked, so let's make sure we mark that. All right, so I'm trying to prove these triangles congruent. I don't have enough right now. I have 2 angles, that's it. But again, we have to look for those other things, the vertical angles, the shared sides, the parallel lines, the midpoints. And on this one, I have a shared side. So I can say BC is congruent to BC. And the reason is reflexive property of congruence. And now I have enough. Now I have angle, angle, side. So now I can say triangle DBC is congruent to triangle WBC, and the reason is angle, angle, side. All right, try number 5 on your own. Make sure you mark. There's definitely some things to mark on here. We pause it and we'll go back to it in a minute. All right, so hopefully you paused and tried. EQ is congruent to QP. CE is parallel to PR. So let's make sure those are marked, and the reason is given. So EQ and QP, that's marked. And then CE is parallel, that's not marked. CE is parallel to PR. All right, so right now I don't have enough. All I have is one set of sides congruent. But I definitely have some things I can add. There's a vertical angle right here. So I can say angle CQE is congruent to angle RQP, and the reason is vertical angle theorem. I marked these parallel for a reason, right? This is a transversal. So I can say that this angle is congruent to this angle because they are alternate interior angles, right? These are my parallel lines, this is my transversal. So now I have angle E is congruent to angle P. And the reason I can just use E and P right here where I couldn't use it up here is because there's nothing else that can be angle E, there's no confusion. Down here, I can't call this Q because Q could be this or Q could be that. So I have to be really specific and call it CQE and RQP. But up here, there's nothing else. So I can say angle E congruent to angle P, and the reason is the alternate interior angles theorem. And now I have angle, side, angle. So I can say triangle CEQ is congruent to triangle RPQ. And the reason is angle, side, angle. All right, let's maybe try one more because this is also your homework and classwork. So let's maybe jump ahead. Let me see if I have one that might be a little bit more complicated. So I'm jumping ahead right now. We've done the first side, and we're going to do one more, and then you're going to struggle through these, and you can work with your classmates on these. Let's try, I don't know, let's try number 19 because it's the last one. So number 1, AB is congruent to DC, and AB is parallel to CD. And the reason is given. Let's make sure that's marked. AB is this, congruent to DC. And AB is parallel to DC. And we want to prove them congruent. So I don't have a lot right now. I just have 2 sides congruent, or one side congruent. One side, this congruent to that. But again, I see that I have vertical angles. So I can say that angle BEA is congruent to angle CED, and the reason is vertical angle theorem. And then because these lines are parallel, I can also say, okay, this is a transversal, and I have alternate interior angles which are congruent. So I can say angle B is congruent to angle C. And my reason there is we have alternate interior angles theorem. Now, I could also say, this is another transversal, and I could put these, but do I need to say those angles are congruent? No. Because I could say angle A is congruent to angle D by the same reason. But I don't need that because I already have angle, angle, side, which is all I need. So I have triangle AEB is congruent to triangle DEC. And the reason being angle, angle, side. All right, so hopefully that gave you a good start. You need to, as you go through, you need to mark the things that you're given because they're not always marked in the drawing. So make sure you're marking what's given. Make sure you're looking for things like vertical angles, shared sides, parallel lines, which could give you alternate interior angles, or possibly a midpoint, which could also give you congruent segments. So make sure you're looking for those. Take your time and then figure out which of those do you have. Because again, what you're looking at is, can you prove them by side, 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 angle, side, angle, angle, side, angle, angle, side, or hypotenuse leg? Which one of those can you use? And remember, there is no ASS. All right, guys, good luck. Work with each other. And this is your homework and your classwork.